video looks at arithmetic sequences. Arithmetic sequences are sequences in which the difference between the terms is a constant. The constant is often referred to as the common difference, and we use D to denote the common difference. So here's an example right here of some terms. This is a sequence. What do you notice about these numbers? To go from 2 to 5, you add 3. To go from 5 to 8, you add 3. That means that D is 3, the common difference. And D can either be positive or negative. Now let's look at the first example. Determine the common difference in the next 4 terms of the arithmetic sequence. So we're looking for what's the difference between those two terms? What's the difference between those two terms? To find the common difference, you can subtract the second term from the third term, or the first term from the second term. So in this case, negative 36 minus negative 53 gives us 17. To ensure that this is arithmetic, we can do it a second time. Notice that the difference between A3 and A2 is also 17. D is 17. Now that we know that the common difference is 17, in order to find the next 4 terms, we can just continue to add 17 each time to find each next term. So to find A4, add 17. You get negative 2. To find A5, add 17 to negative 2. You get 15. To find A6, add 17 again. 17 plus 15 is 32. To find the next term, A7, add 17 again. 17 plus 32 is 49. So, we added the common difference D to each term to find the next term. And therefore, the next 4 terms are negative 2, 15, 32, and 49. So now it's your turn to try. Determine the common difference and find the next 4 terms of the arithmetic sequence. So which one of these is D? And once you find D, A, B, or C, which one of these choices gives you the next 4 terms? Take a minute to pause the video, try this guided practice on your own, and then check your answer. The answer should have been A. The common difference D was negative 6, making the next 4 terms 50, 54, 38, and 32. So we've looked at arithmetic sequences. Arithmetic sequences are lists of terms. And the terms themselves are equally spaced apart. In other words, there's a common difference between them. The difference between an arithmetic sequence and an arithmetic series is that the series is the sum of those terms, the sum. So if you see a sequence, you'll notice that you'll have commas separating your terms. And if you see a series, you'll notice that you'll see addition signs separating your terms. We're going to be looking at how to find the sums of infinite arithmetic series. We don't want to have to just add them all together, so of course we're going to have a formula. This is the main formula that we're going to use down here, but there's also a formula that's a second formula if you don't know the second term. Find an explicit formula and a recursive formula for the nth term of an arithmetic sequence. So first we want to find D, the common difference. So how far away is 14 from 3? Looks like D is negative 11. The second thing that we want to do is we want to set up our formula for the nth term. So we know that D is negative 11. So this is the nth term formula. In the nth term formula, we're solving for a sub n. This always stays here because we're trying to figure out a formula so that we can find the nth term of any list. In other words, I want to be able to find the 9th term or the 50th term. And then the things that we need to plug in are A1, right? That goes in here. And then we need to plug in D. That goes in here. And then we want to simplify the expression. So I'm going to distribute the negative 11. That would give me 14 plus negative 11 plus positive 11 minus 11n, and then I want to simplify this all the way down. So my nth term formula is going to be let's go back for just a minute. So my nth term formula is going to be a sub n equals negative 11n plus 25. Or you can write this as 25 minus 11n. So this is what we call an explicit formula because you're solving, this is an n. You're solving so that you can find the nth term, and you should be plugging in n. It's a function of n, the place number that you're at. Okay. To find a recursive formula, note that in order to find the next term, you have to take the previous term and then subtract 11. Anytime you give a recursive formula, you have to give the first term. So this would be my recursive formula. Let's take a look at a practice problem. Take a minute now to pause the video and try this on your own. Find both an explicit, that's going to be a sub n in terms of n, and a recursive, that's where you'll do a sub n in terms of a sub n minus 1, for the nth term of the arithmetic sequence. Here's your sequence. You should find that the answer is C. The explicit formula is a sub n equals 18n minus 3, and the recursive formula is a sub n equals a sub n minus 1 plus 18. Let's take a look at this example, example 3. Find the 41st term of the arithmetic sequence. Since they're asking me to find the 41st term, that's n equals 41. The best way to do this is to first find a formula for a sub n and then plug in n equals 41. So I'll start by finding the common difference. You may notice that the difference between the terms is always the same, or negative 7. That's my value of D. And I'll just double check to make sure that all the terms have a difference of negative 7, and they do. Here's my nth term formula, just like we used in the previous problem. I'm going to plug in D, my value of D, right here, and I'm going to plug in my value of A1 right here. And I'm also going to plug in n equals 1. N equals 41. And then simplify. So the 41st term of the sequence is negative 269. Let's find the first term of an arithmetic sequence when they are giving me a term. A of 44 equals 229 and D equals 8. And this time I'm trying to find the first term, A1. First thing I'm going to do is set up my formula. Then I'm going to plug some stuff in. So like for instance, I can plug in A of 44 equals 229, and I can plug in D equals 8. I also know N. In this case, N is 44. Once I've plugged in a sub n, and d, it should be fairly easy to solve for the remaining variable, which is a1. So that's what I'm going to do. So I'm plugging in 44 for n, 229 for a sub n, and 8 for d, and simplifying that expression leaves me with a1 is equal to negative 115. Therefore, the first term of this sequence is negative 115. All right, now it's your turn. Find the 25th term of the arithmetic sequence 49, 40, 31, ... Remember, use your a sub n formula and plug in all the values you know to solve for n. Try it now, pause the video, and then check your work. You should find that the correct answer is B, negative 167. Let's talk a little bit about arithmetic means. Arithmetic means are the terms between two given terms of an arithmetic progression or sequence. For instance, 3 arithmetic means exist between 2 and 18 in this sequence, because these are the 3 terms between 2 and 18. Let's take a look at example 4. Write the arithmetic sequence that has 5 arithmetic means between 6.2 and negative 1.6. Negative 1.6 is the 7th term, right? This is A1, this is A2, A3, A4, A5, A6, and A7. What you might know is that you've added the common difference 1, 2, 3, 4, 5, 6 times. In other words, (6.2) plus 6d equals negative 1.6. This is the equation that we need to solve in order to solve for d. So let's subtract 6.2 from both sides. We get negative 6d equals negative 7.8. Divide both sides by d. Not divide both sides by d. Divide both sides by 6. And we get d equals negative 1.3. So now that I know d equals negative 1.3, looking back at my original sequence, I can just add negative 1.3 to 6.2, and then I can add that value repeatedly until I make sure that doing it 6 times gets me to negative 1.6. So let's take a look at that. To find A2, add D once. Okay. Then to find A3, add D again. To find A4, add D again. To find A5, add D again. And lastly, to find A6, add D again. And then I probably want to just double check, add D one more time, and make sure that I do in fact end up at A7, which in this case was negative 1.6. All right, now it's your turn. Take a minute to try this on your own. Write an arithmetic sequence that has 5 arithmetic means between 16.2 and 14.7. So remember, you're going to have 5 empty spaces between 16.2 and 14.7. Solve for D, and then find the missing terms. Try it now, and then when you're ready, resume the video and check your work. You should find that C is the answer. And these are your 5 arithmetic means between 6.2 and 14.7.